this video, we will discuss how to find a normal probability from a problem using a z-score and also without using a z-score. Let's look at this example. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal, with mean 266 days and a standard deviation of 16 days. We're going to find the following probabilities. So the first thing we need to do is look at the words approximately normal. Because of that, what does that mean? Well, that means we can draw a normal curve. And so let's draw a normal curve. On this normal curve, what is at the center of the curve? 266. So we're going to look at the following days that they want us to find. And the first one says, what percent of pregnancies last less than 240 days? That's about 8 months. So drawing a curve, again, setting the mean to 240, or to 266. We go ahead and locate 240, which is to the left of 266. Now, what we need to do is find a z-score. So to find the z-score, what do? Well, we take each, remember z is equal to x minus mu divided by sigma. And here our parameters for this curve are x follows a normal distribution with a mean of 266 and a standard deviation of 16. So we're going to do z is equal to our x, for this case is 240, minus, so we do 240 minus the mean, which is 266, and we're going to divide that by standard deviation, which is 16. And we get a z-score of negative 1.625. Well, why is the z-score negative? Because notice the 240 falls less than the mean. Now, on your curve, what you're going to do, you're going to draw a curve, and this time we're going to make that mean of that curve, because this is a z-score. What is the mean of that curve? The mean will be 0. So let's draw a curve. Set the mean to 0. Negative 1.625 is on the left-hand side. So on the left-hand side of 0. And we're going to shade this, since we were lower, then we're going to shade to the left. Now, we're going to use our calculator to find this area. And remember, we talked about this. When we look at this curve, we're going to first off use the normal CDF. So that's second bars, normal CDF. And we're going to do, our lower bound here is negative 99999. So on the left-hand side is going to negative infinity. We need a number for that. So we give it negative 99999. Comma, we're stopping at what value? Well, we're stopping at the value of the z-score, which is negative 1.625. So we're going to stop this at negative 999, stop this at negative 1.625. And remember, the z-score, so our z-score is going to be, for the mean, we put a 0. For the standard deviation, we put a 1. Calculate that, and we get this here, 0.05. So there's about 5% chance that a pregnancy will last less than 240 days. Now, there is a much quicker way to do this, and this is the way I want to show you in this video. So the quicker way to do it, to bypass all this, is to skip the z-score step, and to just change this mean from 0 and the standard deviation from 1 to the mean of the problem and the standard deviation of the problem. So here's what we have now. We're going to draw another curve. And on this curve, we're going to set the mean of the curve to 266. And we're going to locate the value they give us for x, which is 240. Well, 240 is to the left of 266. So we're going to shade, this curve to the left because it's a lower curve and it says lower than 240 days. And this time, we're going to go second, bars, normal CDF, negative 99999. Lower bound. The upper bound this time, instead of doing the z-score that we just found, we're actually use the actual x from the problem, which is 240. And we're going to change the mean to 266. And let the standard deviation be that of 16. Close parentheses. And we'll press enter. And notice we get the exact same value. So this is a much quicker way to get the exact same answer, but realize that it's coming from the z-score process. So let's do the next one. what percent of pregnancies last longer than 285 days? So again, what we're going to do, we're going to draw a curve, set the mean of that curve to 266. We're going to skip the z square step. So our mean's at 266, and we're asking about 285. We don't know longer than that. So 285 is to the right of 266. We're going to shade to the right. And in our calculator, we're going to go second, vars, normal CDF. This time the lower bound, because we're on the right-hand side, if you look at your curve, it says that our lower bound is 285. Our upper bound is going to be, this time because we're to the right, we're doing 99999. And our mean, because we're not going to use z-scores, we need the actual problem, our mean is 266. And our standard deviation is 16. We calculate this, and we get 0.1175. Now, the last problem says what percent of pregnancies last between 240 and 270 days, or between roughly 8 and 9 months. Draw a curve again. And this time we're looking at 240 to the left of that value of our mean, which is 266, and 270 to the right. And we're going to find the area that's in between those two values. So in our calculator, we'll go second, vars, normal CDF. This time your lower bound is going to be the 240. Your upper bound is going to be the 270. So this time you're not using any of the nines because you actually have lower and upper bounds. Your mean is 266. And the standard deviation is 16. And we get 0.5466. And so that'll be 54.66% of pregnancies last between 8 and 9 months. Now, so again, there's two ways to do this. You can either find z-scores. You find a z-score, you get the exact same answers. But there's a quick way to do it, which is just plugging in from the problem, what you're already given.